In this recording, I'll be looking at solving absolute value equations and inequalities. So first of all, let's look at a couple simple problems here. If I asked you what was the absolute value of 3, hopefully you would say 3. Or how about the absolute value of -3? Well, that's also 3. So our definition here says the absolute value of a number is its distance from 0 on the number line. So because it's a distance, it's always going to be positive. And in fact, if you draw a number line, you can certainly see the distance from 0 to 3 on the number line is 3, and that's also true for -3. All right, so let's look at some problems here. On number 1, it says find the distance between -15 and 7 on a number line. Now, sometimes students will just add these two numbers. That's not correct. If you actually look at a number line, so basically we're looking at this distance plus this distance here. And so it's basically going to be 15 plus 7, or 22. So how do we do this? Normally we just subtract. To find the difference between two numbers, we subtract them, and that'll tell us the distance, except for, notice here, it would be negative, so we actually have to put an absolute value around it. So you subtract the two numbers and use absolute value to make sure that you get a positive answer, because distance is always going to be positive. And so if you subtract here, you get the absolute value of -22, which is 22. All right, so let's look at number 2. It says solve each absolute value equation, graph your solution. So we're going to start simple here. So notice we're looking at absolute value equations, and so let's see, here we have absolute value of x is equal to 5. Well, think about this. If you take the absolute value of some number and you get 5, there's two possibilities here. Either x is -5 or x is +5. I mean, we saw that up above with 3 and -3. So the only two values we could get here for x that make this equation true are x equals -5 or x equals 5. So the way we're going to write our answer, it looks like this. This is what we call the solution set. And it's just telling us there's two answers. And let's go ahead and graph those two answers. All right, so now let's look at number 3. So whatever's inside the absolute value here, in this case x minus 4, that's either got to be equal to 9 or -9. Because we know if you take the absolute value of number and you get 9, then there's two possibilities. You're taking the absolute value of -9 or +9. And so basically we take what's inside, that x minus 4, and set it to -9. Well, we say x minus 4 equals -9, or x minus 4 is equal to 9. And so we'll add 4 to both sides, we get x equals -5. On the other side, we'll add 4 to both sides, we get x equals 13. So our solution set here, and this is an OR, we have two answers here. Our solution set is -5 and 13. And so again, I'll go ahead and graph those, or plot those on a graph or a number line. Now, I think one of the things that can be helpful to making sense out of this, if you're still having a hard time seeing it, is when we plug in the numbers. Let's see, absolute value of -5 minus 4. Well, this is the case where we end up with -9, and the absolute value of -9 is 9. So that's our negative case. And if we subtract, if we plug in 13 for x here, we get the absolute value of 13 minus 4 equals 9. And this is the positive case where you have the absolute value of a +9 is equal to 9. And of course, that's also true. So in general, when you're solving an absolute value equation, you're going to get two answers, basically a positive case and a negative case. And so that's what we're looking for. However, just be aware there are two other cases that can occur. I'll mention those in just a few minutes here. All right, let's move on to the next slide. So if you look at number 4, it's very tempting. You know, I'll get students that'll do this. They'll add the 3 and the 5 here, and they'll, I don't know, there's maybe get something like 2x plus 8, or maybe they'll leave the 2x inside the absolute value and the plus 8 will be outside. The thing is, we don't know that we can add a number that's inside the absolute value with something that's not. In fact, we can't do that. If you, in general, if you're not sure you can do something in math, generally it's probably not a good idea. You can only do the things that you know you can do. So I do know that I could subtract 5 on both sides. And in fact, by doing that, now it looks a lot like the one we just did. However, hopefully a little red light went off in your brain when you see that -3 on the right. Because we know if you take the absolute value of some number or expression, we don't know what x is here, but when you take the absolute value of what's inside the absolute value symbol here, you should get a positive number. In fact, you could never get a negative number. And so there is no solution to this. Our solution is the empty set. Remember, we could also write the empty set like this. And so, but what if you're just plugging along and you set this equal to -3, excuse me, and +3. You get -3 on the left here. So I subtracted 3 on both sides. You get 2x equals 0, which means x will be 0. Okay, so we got two solutions here, but notice if you plug it in, you get the absolute value of -6 plus 3, which is the absolute value of -3, which is 3. 3 plus 5 is not 2. And I'll just tell you, if you plug in 0, you get the same sort of deal. It doesn't work. And so, number one, you either got to remember that the absolute value of some expression cannot equal a negative number, or you'll need to get in the habit of checking your answers so that if you have a situation like this, you'll catch it when you check your answer and you'll see, oh, shoot, this is not possible. There is no solution that will make this original equation true. All right. So I would encourage you to try number 5 and then watch the video. All right, let's see how you did. You should have divided by 3 first. And basically what you're doing is isolating the absolute value first, because once we do that, we know what to do next. We basically take whatever's inside and set it equal to the positive and the negative of the number on the right. So this will become x minus 4 is equal to -4, or x minus 4 equals +4. And if I add 4 to both sides on the left here, -4 plus 4, we do get 0. And if we add 4 to both sides on the right here with x minus 4 equals 4, we'll get x equals 8. All right, so 0 and 8, those are our two numbers, x equals 0 or x equals 8. This is our set notation. Well, actually, it's not really set notation. I guess it is considered set notation, other than I don't have the braces. But our solution set is going to have 0 and 8. There's two solutions to this. And let's go ahead and plot those points. Excuse me. So let's talk now about absolute value inequalities. It says graph each of the following using the meaning of absolute value. Using the graph, write the solution to the absolute value inequality in set notation and interval notation. All right, so first of all, we have the absolute value of x is less than 3. But remember, absolute value is distance from 0 on the number line. And so what does this really mean here when we have the absolute value of x is less than 3? That means the distance from x to 0 on the number line is less than 3. The distance from x to 0 is less than 3. So let me go ahead and plot 3 here. And so basically, notice like -1, -2, these are values, or these are locations on the number line that have a distance from 0 that's less than 3. In fact, we'll go all the way up to -3, but all these points in here have a distance from 0 that's less than 3 units. And the same thing happens on the other side. All of these points are less than 3 units away from 0 on the number line. All right, so what does our graph look like? It looks like that. Basically, x is in here. That's what this expression is telling us. The absolute value of x less than 3 tells me the distance from x to 0 on the number line is less than 3. And all these points have a distance from 0 that's less than 3 units. So basically, our first step when we have an inequality like this is to rewrite it in set notation form. Basically, this is what I call the between case, where x is between -3 and 3. We're between two values here. And in interval notation, it would look like that. So it's open parenthesis, or parenthesis, -3, comma, 3, again parenthesis. And so that's how you express the numbers that are between -3 and 3 and don't include the endpoints -3 and 3. All right, so go ahead and look at number 2 and think about how that would be different from the one we just did. See if you can do the problem. All right, so here the distance from from x to 0 is less than or equal to 3. And so it's going to look very similar. The only difference is you're going to have brackets at 3 and -3. 3 and -3 are part of the solution here. Because we have the distance from x to 0 is less than or equal to 3. It can equal 3, and so we do include the endpoints here. In set notation, it'll look like this: -3, or let's see, x is between -3 and 3, where you have less than or equal on both sides of x. And then when you write it in interval notation, it'll be bracket -3 to 3, and again bracket on both ends. All right, so why don't you look at 3 and think about what that might look like, and then watch the video. All right, so on number 3 here, so what we have here is the distance from x to 0 is greater than 3. All right, well, so here's -3 and 3 on the number line. Notice, like for example, if this were 4, 4 has a distance from 0 that's greater than 3. In fact, any of the points to the right of 3 here have a distance from 0 that's greater than 3. And so our graph ends up looking like this, because you have that happening on both sides. So these are the points whose distance from 0 on the number line is greater than 3 units. The distance is more than 3, basically. And so you have, before on numbers 1 and 2, you had everything between two numbers, and that's what we get with the less than or equal case. I call this, for that reason, the and case. Excuse me. Where you have everything in between two numbers. What we have here is what I'd call the or case, where you have everything outside of two numbers. All right, so how would I write that? First of all, in set notation, well, on the left here we have x less than -3, and this is an or statement. or, because this is basically a union, you have the stuff on the left side of the graph and on the right side of the graph. This is all part of our set. It's a union of two sets. And so on the right we have x is greater than 3. And again, the reason why we use the word or is because you can't have a number that's less than -3 and at the same time also greater than 3. You're basically over here or you're over here, but you can't be both. All right, so this is the OR case where we have everything outside two numbers. In interval notation, going from left to right, let me change colors here. So we're starting out in negative infinity territory. We get to -3, and we're going to union that with everything from 3 to infinity. All right, so now you're going to be solving absolute value inequalities where you have something other than just x inside the absolute value, but you're going to have these same types of answers based on whether you have a less than symbol or greater than symbol. All right, so let's move on to 4 here. So basically, we have a summary of absolute value inequalities. Now this is in general over here. It's probably easier to look at some examples. So if you have x is less than 5, that's telling you that this is the AND case or the between case where you have x between two numbers, -5 and +5. And the only difference with the less than or equal is this, you have less than or equal signs in the inequality here. All right, and whereas if you have, so this is our AND case, or AND cases, and then you have absolute value of x greater than 5 and absolute value of x greater or equal to 5. These are our OR cases. Notice we end up with an OR statement. And again, it's where you have everything outside of two numbers instead of everything that's in between. All right, and again, the only difference for the last one here is the equal symbol. All right, so I would encourage you to try 4 and 5 and see if you can rewrite it in this form to the right here. And then you're supposed to graph your solution and write it using interval notation. All right, so with number 4 here, basically this is the between case or the AND case where x is between two numbers, basically the positive and the negative of 2, and your symbols should be less than symbols. So basically you have x is greater than -2 and less than +2. And when you graph that, it's everything between -2 and 2. And so -2 to 2 with parentheses on both sides, that's how we would write that in interval notation. Now on number 5, this is the OR case, where you're going to have everything outside of two numbers. And so, on the right side what you see, now this looks just like the one we have up here, absolute value of x greater or equal to 5. Notice on the right side, oops, let me erase here. Notice on the right side, it looks just like it does when you have the absolute value symbol. You just drop the absolute value symbol. But what about on the left side? Notice, so not only do we have the opposite symbol, so instead of greater or equal, it's less than or equal, you also have the opposite sign. So on the right, it looks just like what we have in the absolute value form. Just drop the absolute value. And on the left, it's going to have the opposite symbol and the opposite sign for the number. So we have x is less than or equal to -4. So hopefully it makes a little bit of sense, why we're translating this to this OR statement. But the most important thing is that you can do that first step. That is the key first step. And then of course when we graph that, we're going to graph everything less than or equal to -4, so we'll have a bracket on that. It'll be -infinity to -4 with a bracket. And then on the right we'll have from 4 to infinity. So in interval notation, -infinity to -4, Again, we're working left to right. Then we union that with everything from 4 to infinity. All right, let's move on to our last slide here. So basically, we have two cases. We have the AND case, we have the OR case. And our first step is simply translating, basically getting rid of the absolute value and writing a compound inequality. So this is the AND case or between case, where you're going to have everything in between two numbers. So x plus 1, what you have inside the absolute value, is going to be between the negative and the positive of 5. And so notice here, we're not solved for x. Remember, with a compound inequality like this, we need to get x isolated in the middle. So we'll subtract 1 on each part, and now we've got this thing solved. X is between -6 and 4 and includes those endpoint values. On a number line, you're going to graph everything between -6 and 4. We use brackets because we're including the equal case, the endpoints. And in interval notation, we have bracket -6 to 4 bracket. All right, so I would encourage you to maybe try number 7 and then watch the video. All right, so this certainly is the OR case, and we're going to end up with an answer where it's everything outside of two numbers. That's what we're expecting. Now again, we can drop the absolute value symbol on the right. We're going to have 3x minus 4 is greater than 2. And then our other statement is going to be 3x minus 4, but we're going to have the opposite symbol and the opposite sign. So 3x minus 4 is less than -2. Now, the most important thing is that you can do that step. Basically, I want to show you what's going on here. I'm going to make a number line up here. And we've got -2 and +2. And let me get a different color to shade here. So basically, you have this side over here and this side over here, where the distance from 0 to 3x minus 4 is greater than 2. We're basically saying 3x minus 4 is either here on the right, where it's greater than 2, that's this statement, and on the left, or the other possibility is this number 3x minus 4 is a distance, again, greater than 2. It'd be on the left side where we're more than 2 from 0. So that's the idea here. That's what's really going on. But the most important thing is that you can go from here to here. And hopefully it makes some sense that we're rewriting it as this OR statement. All right, so then we can solve each of these separately. When we add 4 to both sides here, we get 3x is less than 2. We'll divide by 3, and we get x is less than 2/3. On the other side, 3x minus 4 is greater than 2. We'll add 4 to both sides. We get 3x is greater than 6. And if you divide by 3 on both sides, you get x is greater than 2. So again, this is an OR statement. X is less than 2/3, or x is greater than 2. So again, we got what we expected. We're going to have two areas outside of two numbers, or our solution will include what's outside of two numbers. If you graph this, x is less than 2/3. We're shading everything to the left of 2/3 on the number line, and we're shading everything to the right of 2 on the number line. And so our solution is -infinity to 2/3 union 2 to infinity. All right, and so that's it for this video.